Hello everyone, my name is Oskar and I'm the Assistant Director of Bioscience Institute from Novi Sad as well. So please give me an angry look or wave when I'm close to the end. So I'd like to ask you to run the presentation. Yeah, there it is. So we are an institute that combines two types of technologies. The first one is AI, or data science, sensor development, etc. And that's the state-of-the-art technology of the 21st century. But the other state-of-the-art technology used to be state-of-the-art technology 10,000 years ago, and there's agriculture. So we're combining the two contrasts to get something like this. And this is one example of what we do. So today we're going to talk about blueberries. They're getting quite popular in Serbia. They're coming from North America, and there are two different varieties. There's a northern variety and a southern variety, and we are lucky enough to have the northern variety, which has got perfect conditions here in Serbia. This is a high-value crop, so it really pays off to invest in new technologies for growing blueberries, and they grow for almost 50 years, and that's why the farmers say that that is something that you leave for your grandchildren. So we have two use cases, one in Serbia, one in Lithuania, and we're applying the technology at both places, but there is a problem. There is a big gap between engineers and the farmers, and usually when we're speaking about blueberries, you know, when you say blueberry to a farmer, he means fruit. When you say blueberry to a geek, it means Lieutenant Blueberry, and that's quite hard to really marry to sight. But we're trying to do that, and we're getting there. So one of the problems that we've got in blueberry production is that you need to sample the soil as many as 12 times during the season, and it's very, very laborious process. You need to get out to the field to dig out the soil, and then you need to carry it to the lab to analyze it, and you get the results after 2 weeks, and then after that you can optimize your decisions regarding fertilizer, regarding pesticide, watering, etc. The second problem is weeds and diseases. So again, you need to manually eradicate the weeds, you need to go to the field, etc. And these jobs are something that no human wants to do. And I think this is as close to sociology and as I'm going to get today. So sorry for that. But anyway, instead of hiring people to do these tedious jobs, we can use robots to do that instead of us. So there are 4 use cases that we set up on the blueberry field. So we've got monitoring, then soil sampling, detection of weeds and diseases, and last but not least, spraying. Regarding monitoring, we installed sensory systems. We've got weather stations, soil moisture sensors, and then based on that, we're optimizing irrigation through the AgroSense platform. And this platform, I'm going to brag a bit about this, but 20,000 farmers in Serbia are using the AgroSense platform, which is when you combine all the farmland that's being managed through this digital platform, you get 1/4 of all Serbian farmland. So this means that 1/4 of all areas in Serbia are digitized. We're using a drone. This is a multispectral drone, which we use to get these images like that one. Then we're calculating vegetation indices. Basically, green is good, red is bad, and that's what we're using to optimize everything. But we're also using AI to really understand what's happening in these images. So just as you're recognizing the emotions, etc., in Facebook images, we're recognizing the emotion of plants. And we need to know whether the plants are growing well, whether they need to have some water, fertilizer, etc. But in this example here, where we have the data, we have the label data sets, thanks for the students, and we're getting the outputs which are then being processed. But the bottom line is that after everything, you get the rows. And that is what we are giving to the robot. So these rows, so the robot knows through how can it go through the fields. And then one step after that is that we're using these rows and we're using unsupervised machine learning, etc., to zone the field. So each of these zones has got homogeneous properties inside of it, but between one another, those zones are quite different. So when you're extracting the soil, you need to get one sample out of each zone. And instead of sending people to do that, we're sending robots to do it. And robots are going through the fields, they're positioning themselves automatically, they're extracting the soil and analyzing it. So you can see this gadget here, this construction, and there is a soil sampler. So there is this expression in the Balkans: if the mountain won't go to Muhammad, Muhammad will go to the mountain. And here, if we're not taking soil samples to the lab, we're taking lab to the soil samples. And that's by far more efficient because you can get the samples analyzed in like 15 minutes instead of 2 weeks, and you can automatically optimize all the decision-making on the field. But there's a lot of hard work involved, so it's not just AI and Python code. There are some snakes there as well, but it's not Python, definitely. So you need to measure what's happening with the wheels, how the robot is going through the mud, etc. And this is what the robot actually looks like. And this is an artificial blueberry field for training the artificial intelligence. So it goes just to get those agile cycles working properly. But we're also sending the robot to the field, and I've got some videos that I can maybe show you a bit later. So this contraption here, which looks like NutriBullet, is actually the NutriBullet for the soil. So when you extract the soil samples, you put it inside this NutriBullet, so you dissolve it in the water, and then you take some pH probes, different sensors that we're developing, but also the commercial sensors, so you can get some information about, as I said, the pH value, electrical conductivity, the level of nutrients like potassium, phosphorus, nitrogen, etc. So in 15 minutes, you can get this kind of analysis, so you can fertilize the plants on the go. I don't know if the video is working, but maybe you could run the other one that I transferred, so either one of those would be fine. Thanks. Oh. Yeah, no, okay. I'm wrapping up, don't worry. So this is the robot, this is how it's positioning. So nobody's using the steering wheel, nobody's using a joystick. So the robot is actually detecting the plants. It's positioning itself perpendicular to this ridge, and then it's extracting the soil. But this lasts for 15 minutes, and I've got only maybe a minute or two more, so I won't bother you more with this. But I would like to thank you very much for the opportunity to speak about robots, AI, and plants. So thanks.